Hi, in this video, we are going to learn how to solve exponential inequalities. Before we solve any exponential inequality, let us first explore on the ideas. On the screen, we have the graph of y equals b to the x, where b is a number greater than 1. As we know, when the b or the base is greater than 1, the graph of b to the x will have an increasing graph. Meaning to say, as the x gets larger, let's say from 0 to 1, the y value is also getting larger. Or, in other words, if we have a smaller b to the x compared to another b to the x, then we can say that the exponent follows the same inequality. So x1 is also less than x2. Now let's look at another case. If b to the x1, as we know, is greater than b to the x2, then the x1 is greater than x2. So these two statements, when we summarize, will say that when working with exponential inequalities, the inequality is preserved. So from b to the x, when you relate that, or when you relate the b to the x with less than, then the exponents of this corresponding b to the x will also follow the same inequality. Now note that this rule will apply even for less than or equal, or the greater than or equal inequalities. Now what about the reverse? That is when we have the function b to the x having a base that is less than 1 but greater than 0. As we know from the previous lessons, the graph of this y equals b to the x will have now a decreasing graph. Meaning to say, as x gets larger, the y value gets smaller, as opposed to the first function when the base is greater than 1. So what will be the effect of this when we are working with inequalities? It means that when b to the x1 is less than b to the x2, as we can see, increasing and decreasing, it takes an inverse relationship. So when the b of x1 is smaller than another b of x2, then the exponent actually of the b of x1 is greater than that of the one having the x2. Or in reverse, if we know that b to the x1 is greater than b to the x2, then the exponent will have the opposite inequality, less than, so x1 is less than x2. So unlike the first function where b is greater than 1, when we are faced with an inequality with basis of having a fraction greater than 0, less than 1, the inequality is reversed, as we can see from the two statements. Take note that this same rule will apply even for less than or equal and greater than or equal inequalities. So even if we change the inequality to a less than or equal, greater than or equal, the rule will apply. Again, keep in mind, when the base is less than 1 but bigger than 0, from a given exponential inequality, the inequality sign should be reversed. To make sense of what we are talking about, let us take a look at some examples. Let us consider this example. So we want to solve 3 to the 5x minus 3 greater than 3 raised to 3x plus 7. To solve this inequality, the first thing that we have to check is the base. The base is 3, and 3 is bigger than 1, meaning this is under the case where b is greater than 1. When b is greater than 1, then the inequality is preserved. Therefore, when we solve this exponential inequality, all we have to do is to get 5x minus 3 and that of 3x plus 7. We have to preserve the inequality sign. Solving this inequality is now solving the new inequality. So this will be, if you manipulate the inequality, this will be equal to 5x minus 3x greater than 7 plus 3, which is equal to 10. 2x is greater than 10, divided by 2, then x is greater than 5. So this is the solution set for this inequality. Okay, or in another form, the answer is we start from 5, not including 5, up to positive infinity. So this is the solution set. But keep in mind the idea was to check the base. If the bases are the same, then to solve the inequality, you have to preserve the same inequality. Okay? Let's go to the next example. In example 2, we want to find the solution set of the inequality where the base is a fraction less than 1 but bigger than 0. So this is the case of less than 1 and bigger than 0. And as we know, if we have this kind of exponential inequality, the inequality should be reversed when we work on the exponents. Okay, so go ahead immediately and work with the 2x plus 3 and x minus 1. So 2x plus 3 in relation to x minus 1, the inequality will be reversed. So from less than, it will become greater than. And from here, all you have to do is to solve the new inequality. So this is 2x minus x greater than negative 1 minus 3. X is greater than negative 4. So this is the solution set of this inequality. Or you can write your answer as x greater than negative 4 means not including negative 4, but this will be up to positive infinity. So this is the solution set. Next, suppose we have this now. So still under the exponential inequality, but let's look at how is this different to the ones we have already solved. Okay, first, again, same approach. We check the type of base that we have. The base is 4. 4 is greater than 1, so this is under the case of b greater than 1. When b is greater than 1, again, the concept is we have to preserve the inequality. So the inequality is preserved. So we take the exponent. When you take the exponents, x squared plus 4x and 2x plus 3, we solve this inequality by preserving the original inequality, and that is greater than or equal. So to solve the given inequality, all you have to do is to solve the new inequality. So working on a quadratic inequality, this will be x squared plus 4x minus 2x minus 3 is greater than or equal to 0. So in solving a quadratic inequality, we have to set the other side to be 0. So this will be x squared plus 2x minus 3 is greater than or equal to 0. Then you have to factor the given inequality, quadratic expression for the inequality. That's x plus 3 and x minus 1 greater than or equal to 0. Apply table of signs. We have x plus 3, x minus 1, the zeros, find the zeros. This is negative 3 and this is 1, and then you create some sort of number line. So this table of signs is something that we have learned before, or you might have learned before, because this is a prior knowledge for this topic. So I hope you know how to create your table of signs. So from here, you plot the numbers that will make this factor 0 accordingly in proper order, negative 3 and then 1. Plot the zeros where the factors are, or the numbers where the factors are 0. So x minus 1 is 0 at 1. Using test numbers, this will result into a negative, positive, and positive. The second one is negative, negative, and positive. So the product of these two will be applied for the signs. So the product of the signs will be positive times positive is positive, Positive times negative is negative. Negative times negative is positive. And from here, you get the answer based on the inequality. It should be greater than or equal to 0. A greater than or equal to 0 means you take the positives. And that is from, so the solution set based on the table of signs is from negative infinity to negative 3, this time including negative 3 because of the presence of the equal sign in the inequality. There is a gap because there's a minus sign here that we don't need, so we restart from 1, again including 1, up to positive infinity. So this is our solution set. So the only difference of this inequality is that we encountered a quadratic or an inequality leading to a quadratic inequality. Okay, but the ideas of preserving or reversing the signs are still applied and the same. So what I would like you to do after this video is to try out the following examples or exercises. I need you to try number 1, 4 raised to 3x plus 2 greater than 4 raised to x plus 8, and number 2, 1/5 raised to x squared minus 4x less than or equal to 1/5 raised to x plus 6. To know the answers for these inequalities, you can use Wolfram Alpha, which is a very good program. You can have the web version of this. You input the inequalities and there you can have the answers to these exercises. Again, check out. This is a good website, Wolfram Alpha. All you have to do is to input each inequality and then and the program will just give you the final answers. Okay, so that's all for this lesson. So I hope you know now how to solve exponential inequalities. Thank you and goodbye.